Hello folks, we are back with the next video of this problem number 8. We can see the problem number 8 on the board. It has got a linear in the numerator, and there is actually you have got linears in the denominator, actually 3 linears, but only thing, one of the factor is a repeated factor. It's like x minus 1, x minus 1 and x plus 2. We have not done problems of this type. So like the previous problem, this is going to be calling for a different substitution. So we'll check now what substitution we can do here whenever you have such repeated factors. Though they are 3 linear factors, but still it's a repeated factor. So for a repeated factor, we use a different substitution. So let's consider this. Consider the x over x minus 1 square times x plus 2. Whenever we have problems like this, we make a substitution a over x minus 1, that is one factor. Then you take b over x minus 1 the whole square. Look at this. There is because it's a repeated factor, first time you will take it just once, and second time you will take it with a square, and then c of course will be the third factor. So this is how we make a substitution if you have a repeated linear factor in the denominator. So let's take care of this because we haven't done this earlier. So though when we had 3 linear factors, we used to take a over the first one, b over the second one, and c over the third one. But here it's not like that. It's a repeated factor. So when it's a repeated factor, we take a over one factor just once, and the repeated factor is b over raised to 2, that way. So that care we have to take. Now as usual, we'll try to equalize. We know that you should get this as this is our LCM. In order to get the LCM here, this part, it's very clear, has to be multiplied by x minus 1 times x plus 2. To get this LCM, you know that this has to be multiplied by x plus 2, both the numerator and the denominator. And this part, it's very clear, has to be multiplied by x minus 1 the whole square. That's how you get this as the LCM. So we'll have now a times x minus 1 times x plus 2, b times x plus 2, and c times x minus 1 the whole squared. Here it's x over x minus 1 the whole squared, x plus 2, denominator is also that. So we come to know that the denominators can cancel each other. So as a result, our new expression is a times x minus 1 times x plus 2 plus b times x plus 2 plus c times x minus 1 the whole squared is our x. So we know that we should get the ABC value. For that we have to make substitutions. It's very clear to us that we can make substitution x as 1. We take x as 1, this term and this term will vanish, we'll get the b term. B times 1 plus 2 is going to be 3, which is 1. So b is going to be 1 over 3. That's one thing. So we've got the b value. Now we should get a and c. It's also clear to us that we can take x as minus 2. So let's take x as minus 2. If you take x as minus 2, then this and this is going to vanish, and you'll get the c term. So you'll get c as negative 2 minus 1 negative 3 the whole squared equal to negative 2, x it is, so negative 2. So it's going to be 9 over here. So c will be negative 2 over 9. C is also over. Now let's find out a. Again, we are running short of x values. Let's take x as 0 and see if it's working. Let's look at x equal to 0. So if x is 0, a value we don't know. So a is going to be negative 2. A times negative 2 because 0, yeah, negative 2. B value we know it's 1 over 3. So that's going to be 1 over 3 times 2. And c value also you know it's negative 2 over 9. And 0 minus 1, so it's going to be 1. So that's going to be 0. Not 0. Yeah, it's going to be 0 because it's x. Yeah. So let's have this simplified. Negative 2a. 2 over 3, 2 over 9. So multiplied by 3. So it's going to be 6 minus 2. That is 4 over 9. Or negative 2a is negative 4 over 9. Negatives can cancel. A can become 4 over 9. 2 can go there. So a can become again 2 over 9. Yeah, so a is 2 over 9, b is 1 over 3, and c is negative 2 over 9. Let's come back to the I value. I is going to be therefore integral of a over x minus 1. So 2 over 9 over x minus 1 dx. Next is b. So b over x minus 1. So b for us is 1 over 3 over x minus 1 square dx. And then next is c. So c for us is negative 2 over 9. So 2 over 9, negative is there, I've pulled it out, x plus 2. Now let's make it all right. So it's like 2 over 9 integral of dx over x minus 1, 1 over 3 integral of dx over x minus 1 the whole squared, negative 2 over 9 integral of dx over x plus 2. Now these both are linears, so they will be log on the integral. But this particular term, it is x minus 1 the whole cube. I have told you a linear will always behave like x. So x minus 1 the whole squared is like x squared. So if it's x squared, we generally write x raised to minus 2. So if x raised to minus 2 means its integral is x raised to minus 1 over minus 1. Same way we can apply the integral there. So here the integral is 2 over 9 log modulus x minus 1. Here it is 1 over 3, as I told you, x minus 1 raised to minus 2. So integral is going to be minus 2 plus 1. It's like this, x minus 2, x minus 1 raised to minus 2. So the integral will be x minus 1, negative 2 plus 1, negative 2 plus 1. So that is x minus 1 raised to minus 1 minus 1. So it's negative 1 over x minus 1. So negative sign will be there. 1 over x minus 1. The last term, 2 over 9 is going to be log of x plus 2 plus c. You could club these two terms together because they both are having 2 over 9 and write an equivalent answer. That's all. Yeah, looks quite okay. That should be all for this video. So with the next problem, as usual, we'll meet in the next video. Thank you.